Hi everyone, the topic of today's video is dependency inversion principle. So in this video, I'm going to explain what is dependency inversion principle, why is it important, and how to implement dependency inversion principle in Java. So I'll take multiple examples so that you will get clear understanding of this principle. So when I started learning about solid principles, the dependency inversion was the most confusing principle for me to fully understand. So I'll make sure I'll explain this principle in simplest possible language with multiple code examples so that you get clear understanding of this principle. So please watch this tutorial till the end and you will super clear about this principle. So let's start with dependency inversion principle, and this principle states that high level modules should not depend on low level modules. Both should depend on abstraction, and abstractions should not depend on details. Details should depend on abstraction. So for me, when I first read about this principle, I thought, what are high level modules, what are low level modules, and what are abstraction? So in order to explain this better, let me take a very simple example. Let's first look at a tightly coupled code. So where this computer class is dependent on the implementation of keyboard class. So we are creating an instance of keyboard class directly in computer class. So here computer class is a high level module which depends on the implementation of a keyboard class, right? So computer has a keyboard, so it has a relationship, right? We are using composition, but composition in a wrong way, right? So let me explain you why it's a wrong behavior. Let's assume tomorrow we want to replace keyboard with wireless keyboard or gaming keyboard, right? So in that case, I have to modify the computer class. So I have to go back to the computer class and I have to change this direct dependency. So let's say in case of wireless keyboard, I'll write private wireless keyboard and then the keyboard and then new wireless keyboard, right? So every time with every new implementation, I am modifying the computer class. I mean, which is not good. So it violates the open close principle. So as changes in one module affect another. So what is the solution, right? So let's discuss. I mean, how we can write a better code. So before discussing the solution part, let's go back to the principle and read the principle once again. So the principle says high level modules should not depend on low level modules. Both should depend on abstraction. So modules, both the high level and low level module should depends on abstraction. It means we have to create an abstraction in between, right? So I hope you already understood what abstraction I'm talking about, right? So let's go back to the solution part. So we can use an interface to create that abstraction on which both high level and low level module depends. So computer is a high level module, and instead of directly depending on a specific keyboard, right? So instead of directly depending on a specific keyboard instance, it depends on this input device interface, right? So this is the abstraction layer, and that means tomorrow if I come up with new keyboard, I don't have to modify this computer class. Similarly, keyboard classes, so the different keyboard types, keyboard, wireless keyboard, gaming keyboard, maybe some other kind of keyboard, so are low level modules and they depend on abstraction. So again, they should also depends on this abstraction, right? This input device. instead of computer class directly depending on them. Let's see the code implementation after introducing input device interface. So we first define this interface input device, and it has only one method type. So different keyboard classes implements this interface. So keyboard, wireless keyboard, and gaming keyboard, right? And now let's see the computer class, and now you can see computer class no longer cares which keyboard type is being used, right? So it depends on this interface, right? Tomorrow I can inject any keyboard without modifying computer class, right? And this is the I mean advantage of this dependency inversion principle, right? You can see now our code looks more maintainable, right? And I mean we can extend the behavior without modifying this computer class. Let me take one more example, and this time let's take an example of a shopping cart, right? So in shopping cart uh, has multiple payment options to accept user payment options such as credit card payment, debit card payment, wallet payment, right? So this shopping cart is depending on the implementation of different payment types, right? So so suppose tomorrow if I have to introduce one more payment type, I want to accept payment via PayPal, then I have to modify this shopping cart class, right? So again it violates the open close principle. So shopping cart is a high level module, and it depends on the implementation of low level module, right? So we already discussed how we can decouple this behavior. We can decouple this behavior by introducing an abstraction layer on which both high level and low level module should depend, right? Shopping cart should depends on this interface instead of the concrete implementation. Similarly, the low level modules, so here the low level modules are basically different payment options, and they should also depend on this payment method interface, right? And I hope you get super clear about this principle. So here is an assignment for you. So you have to write a Java code to implement this behavior so that you get clear understanding of this principle, right? So now let's move to the last section, why this principle is important. So dependency inversion principle helps in writing cleaner, modular, and more maintainable code, which we already seen, right? And by coding to abstractions, uh, by coding to interfaces, we improve maintainability and testability of a code. So that's it for this video, and please like this video, share this video with your friends. Thank you very much for watching this video.